Unit 1. Cognitive Psychology. Presentation 3. The Working Memory Model.
In the 1970s, two cognitive psychologists, Alan Baddeley and Graham Hitch, developed an alternative model called the working memory model.
One thing to realise at the outset is that this model is focused on one specific store, the short-term memory store. This is the area of memory that is used when we work on something, such as adding up numbers or trying to remember a phone number. This is why it is called working memory, just short-term memory by another name.
The working memory model was developed to explain a particular research finding called dual task performance. This term dual task performance refers to doing two things at once. Doing two tasks that involve the same sensory modality results in slowed performance on task 1, rather than doing tasks that involve different modalities.
Perhaps an example would help. Trying to memorise some pictures is a visual task, whereas memorising a word list is a verbal task. If you try to do either of these while doing another task, your performance will be affected. But, and here's the important bit, if you memorise pictures while counting backwards, you should find this easier than memorising a word list while counting backwards. The reason is because you are doing either a visual plus verbal task or two verbal tasks simultaneously.
Baddeley and Hitch's model offered an explanation for this research finding. They proposed that there must be two separate components in working memory. One of these is visual and the other is verbal. This means you can do a visual and a verbal task simultaneously with relative ease because they are separate components that function independently.
The separate stores are actually called the visuospatial sketchpad and the phonological loop.
The visuospatial sketchpad deals with visual and spatial tasks, as the name suggests. For example, if you're asked to count the windows on your house, you probably conjure up an image of your house in your mind. You're using your visuospatial sketchpad. This might be further divided into a visual store and a visual notepad that in this model are given the fancy names of the visual cache and the inner scribe.
The other store, the phonological loop, is concerned with sounds, especially repeating words over and over again, which is why it is called a loop. This loop is divided into a phonological store, where the sounds are stored briefly, and an articulatory process, which is where the words are repeated.
In addition to the two stores, there is also a central executive. This is not a store as such, but is essentially the process of paying attention to something. When information enters your brain, you pay attention to it. The central executive sends the information to the visuospatial sketchpad if the information is visual or spatial, or sends the information to the phonological loop if it is verbal. This is described as allocating so-called slave systems to tasks. The slave systems are the visuospatial sketchpad and the phonological loop.
The final component is the episodic buffer. Fairly recently, Alan Baddeley realised there was a slight problem with his model. What if the incoming information wasn't visual, spatial, or verbal? Where does it go? So he created another store, which he called the episodic buffer. A buffer is a temporary store for holding information. Baddeley has suggested that the episodic buffer also coordinates information across the different slave systems and provides a link to long-term memory. Evaluating the working memory model. There are a number of advantages of this model compared to the multi-store model. For example, it presents a more detailed understanding of short-term memory than the multi-store model. It also explains the processes more clearly. For example, suggesting verbal information might be briefly stored or rehearsed.
In fact, this is probably the greatest strength, because the increased detail of the working memory model means it can explain all sorts of research findings that can't be explained by the multi-store model. For example, there are the dual task performance studies that we already mentioned. In one such study, Baddeley showed that participants had more difficulty tracking a light and describing the letter F simultaneously. which are two visual tasks, than doing a visual and a verbal task simultaneously. This supports the existence of two separate stores. If there are separate visual and verbal components, then each functions relatively independently, and we can happily do a visual task with the one component and a verbal task with the other. But if you have to perform two visual tasks, then they're going to involve the same component and interfere with each other, therefore slowing down performance.
Baddeley also showed that doing a task involving the phonological loop and the central executive at the same time slowed performance, supporting the existence of these two separate components.
For the record, the tasks involving the central executive were tasks where the participant had to make decisions, such as creating a list of random numbers.
Another source of evidence comes from brain scans. For example, Bunge used fMRI, which shows the areas of a person's brain that are most active at any particular time. Participants were given two tasks: reading a sentence and recalling the final word of the sentence. They either had to do these tasks at the same time or one after the other. The brain was most active on the dual task performance activity, which reflects the increased demands of doing two competing tasks at once.
A final source of evidence comes from case studies of brain-damaged patients. For example, Shallis and Warrington studied a man referred to as KF, who was injured in a motorcycle accident. After the accident, his long-term memories were intact, but he had partial difficulties with his short-term memory. He could process visual information, such as letters and digits, but couldn't deal with verbal material, such as sounds. This supports the existence of the separate visual and verbal stores.
Altogether, the available research evidence provides strong support for the working memory model. However, there are some important weaknesses of the model.
First of all, some of the components are not very well defined, namely the central executive and the episodic buffer. The processes involved with the central executive are not well explained, and the episodic buffer has yet to be fully explored. Perhaps it's best described as a work in progress.
The second weakness is that evidence from brain-damaged patients might not be reliable. We never know what such individuals were like before their brain damage occurred, so we can't be certain whether their brains weren't actually abnormal in some way before the damage occurred. This means that it might not be reasonable to generalize from such cases to normal groups of people.
A final important point is that the working memory model is restricted to short-term memories, whereas the multi-store model included sensory memory and long-term memory as well. As such, the working memory model is limited in its scope.
So, what can we conclude? The working memory model offers a refinement of the multi-store model, describing short-term or working memory in terms of specialized visual and auditory units. Like the multi-store model, the working memory model produces many testable hypotheses which have led to a wealth of research studies only touched upon here. This is a great strength of the model.